Hello everybody, it's Damon, Crazy Logics 007 on YouTube and Crazy Logics in the forum. This video would definitely be edited. This amp is so big that I'm going to have to figure out ways to make this into a good video because it barely fits on my bench. So anyway, this is a Skar, and let's see if I can raise it up, an SK-4500.1. She's a beast. One of our local competitor install places brought it over and wondered if I could do anything. It was out of warranty, and they were really hoping to get it done in a little bit more of a hurry than what sending it out would do. And so I took a peek at it, so I kind of already know what's wrong with this thing, or should be wrong with it. And so I, looked at it and said, yeah, we should be able to order parts, get it turned over, as long as there's nothing stupid crazy. It's a pretty straightforward fix. This is a big Class D, so as usual, way down on this end, I'm not going to lift this thing up 100 times and show you all the ends, but down on that end is the all the inputs and all that. And so the first thing we always do is we look and see where it was set. Of course, they had turned everything off on this, and it was actually enslaved, so this one may have been strapped to another one. So I worked the switch back and forth and then put it into master because we're going to be repairing it. But all these were all turned down, so no hints as to why this one blew up on that. If you find one with the bass boost turned all the way up, that's probably always the culprit, because people misuse this bass boost and crank it so high, and then they've got the gain cranked up so high, and then they're running at low impedance and they just end up blowing it. Bass boost is tough on amps from what I've seen, because it just really makes them work a lot harder in a place where they're not kind of technically supposed to. So see if we can grab some stuff here. Way down on this end is dual input power, so we're going to put our resistor on there and let that drain, and then I will get the meter. And I'm not sure, I may raise this camera up to give you a better overview, but if it is, I'm going to go through and check all the stuff, show you guys, just because it works on Class D too, not just the AB amps that we're using. But we'll check it out. And I said in the intro to one of the old footage videos, I think it was the final machete video or whatever, this had a blown power supply. I don't think the power supply is at all blown. I think it's just the output stage. So it'll be the outputs, and then way down here, when we get this board out, it'll be a little more obvious. The driver circuit will have to be rebuilt. Also, I've got the garage door up and I got the fan on, so if there's a ton of background noise, I may end up doing a voiceover. So if not, if there's just a little bit of background noise, sorry, but it is hot, and I want to be a little bit cool, a little bit comfortable while I'm working on this, and video recording stuff makes it that much harder, and so it's a balance I'm trying to achieve here. So we're going to put it into diode mode, and now I've got the resistor off that should have drained, and so ground's on the outside, and I'm just putting these probes into the holes here on the power thing. And so, whoa, you guys are shaking, but here we are charging the caps. Now this is on the input. This is putting the negative Waldan diode mode onto the ground, and the positive into the positive power. And if it charges the input caps, which are caps like these, and there's a bigger bank up front, if it charges them all the way up and gives you a 1, oh, I've got my overhead light on, maybe that'll help. Yes, no, maybe, I don't know. Let's do that a little bit. I think we will turn it back on. It's awful shadowy down in there. It'll glare on some of the stuff, but charged all the way up to a 1. So that tells me that nothing discharged or fought against the charging of the input filter caps, which normally means no power supply FETs are leaky, or you don't have any damaged drive or anything down here. So I'm going to put my my probes on, and I've actually already done this, but I want to show it. I'll show it once, and then we'll move on from there. So I got my long probes to get down in here, but when you check the FET, we're going to go leg to leg, and we got a beep. Oh, this is perfect. I want to show this. So let's get this where we can see it. Yes. Okay. So depending on the way you put your probes, because it's positive and negative, it can be charge or discharge and recharge the caps in a different direction. So when I put this on here and it's going to beep, normally you'd say, oh my gosh, that means it's shorted, but watch. See how the number's going negative? Oh, you're not seeing that. I want to make sure you can see that. There we go. Okay, let's do this again one more time. You really, this is real important. So see how but it's charging those caps. Watch, it'll stop beeping. It'll go away. And it would continue to charge just like when we had it on the positive and negative. So we're going to, we check those. We check to the other leg and then come back. So, and that's how you check all the FETs. Now, this is the power supply this way, and so there's 1, 2, 3, 4, 5, 6 FETs per power supply segment, and there's 4 segments. So this is a quad power supply, all paralleled in. In this amp layout, it comes to here, and there are 4 rectifiers. So 2 rectifiers for each, set that then make the rails. These are the rail caps to help smooth out the rail voltage, which provide the rail voltage for the outputs. And so this being as big an amp as it is, it's going to generate probably a very high voltage rail voltage. So we're going to be super careful. We're going to do a lot of discharging with our resistors, stuff like that. But I've tested all the power supply FETs, and none of them tested bad. But I went over here to the outputs, and I'm going to see if I can drag you over just a little here. Yeah, here we go. I'll do the best I can with my homemade little camera mount here. Let's see if we can get this in the shot. Yep. So now we go, and I'm testing. It's hard for me to see on my monitor to make sure you can see. But I go to the next leg. That seems fine. Uh-oh. Let's see. Can you see that? So let me grab just any old FET. So this being the FET that's down in there. Here's exactly what I did. I tested first from this leg to this leg. Then I went there to there. Everything stayed fine. And then when I went here, oh, you guys can't see none of that either. Gee, my knees. This is hard to do with such a big amp. So on that FET, I first went from here. It's jiggling around. From here to here. So these 2 legs. Then I went to there. And then I went to here. And when I did this, that's when it beeped. And so we're going to watch that beep. But you notice the zeros stay on there and it stays beeping, and the wind is blowing, so you may be having trouble hearing that. But it is that tells me, bam, it's bad. Well, I've checked both sides. I'll get that out of the way there. And sure enough, there's a problem on both sides. So I've already taken all the clips off. Used my cut-off Allen wrench that barely fits in the hole of the metal clips and popped them all off. The only thing I haven't done is cut a little slot in here, which allows you to sometimes grab those clips from the side. When I get that cut in another video, I'll show it because that's handy to do. I haven't needed it, but it's one of those little tips and tricks where you can put a half cut. Let's see if I can point here. You would just take your Dremel wheel cutting in this way, and you would take a little half cut, and that makes you a thin slit notch that you can grab the edge of those clips to help pop them out if they come out a little goofy. But anyway, the only thing we should have left on this board, I've taken the ends off, I've looked at it, I know that I don't know if I can reach it. Gee, my knee willikers. Those ones that go down in the plastic standoffs don't like to pop out super easy without giving them a little tug. It's not on this end, it's on the other end, and I'll show it to you as soon as we get good and prepped here. Let me get these other screws out. screws are out. So let's move you back up and over. Let's see if I can get this far end. There we go. A little bit more tilt. Sorry for the shaking. So when I took the end caps off, I shined a flashlight down here in between the board and the heat sink in there and looked, and right here, where's my little pencil to point? Right here, down here, it actually says chassis ground on the top of the board, and there's a little solder joint you can see. Maybe let's see if we can do this. Yeah. So it says chassis ground, and you see right there underneath the CH-GND, chassis ground, there's a solder joint. That's actually a wire that goes underneath the board and is going to have a screw to the chassis. So I knew immediately that I had to take the this end plate over here off, because I'm going to have to slide this whole thing that way to be able to get to that screw and release it, because that's where it's at. So I ended up taking both of them off, but that's why I looked underneath the board, is to find where that ground wire was. Some of them have them up on the end screwed up here, some of them have a little screw that goes there or underneath the clip. This one just happens to have it go underneath there. So the final thing I got to do is get all these. Hey, and they're coming real easy. Oh, just give them the slightest little bend forward. This, finally we get to one that's not. And I might be able to do it with these. I have a big pair of, well, I could grab them real quick and kind of edit this. Big pair of bent needle nose. They work fantastic for this, because what you can do is you can use them as a lever, a fulcrum here, and grab it and pop it free, and so you're not putting much stress at all on anything. You're just popping it free from that. Whoop, there's junk all over it. So you take it, you slip on there, and then you squeeze now, give it a little lever, and see, bam, it just pulls them free if they're hard to pull free. These are coming easy, so I'm just going to snag them and give them just the smallest bend out, because we want to leave this silicone sill pad there. If they don't pull off real easy, that's when I do the little lever trick. We want that sill pad to stay there, because there's one here, here. There's a big one there. There's a big one down here, and we want to leave that all in the amp for now. So these are all coming easy. I'm going to use my other pliers that are a little bit smaller on the tip. I've thought about grinding these a little narrow, but I don't want to mess them up, because I use them for so many things. Big pair of bent needle nose like that is just super handy. Fixing brakes, fixing all kinds of stuff. So that's got all that. You could probably get a fast forward here, maybe, I don't know. And I want to get this thing slid back, show you, and be able to stop the video and get prepped for the next shoot part of this, which is going to be oh, see, there's one that tight, so I can just gently grab it, give it a little rock, and that's what you don't want to do. Just slip off of them, because normally it'll tear up the plastic. It makes it look ugly. Normally doesn't damage them. However, if you're going to slip somewhere like I just did there, where it was on the output ones, which is the ones that are blown. You know, you may end up doing an amp that has all of them blown, so the only ones you want to be careful with are the rectifiers. Oh, there is a clip I missed. So here's my little tool. Can you see this clip right here? Yeah, okay. Sort of you can. Maybe if I... Yeah, you can see it a little better without the light. We'll go back and forth between the light. There it is. That's the little single clip. That's for the temperature sensors. Way down here... Oh, here we go to movie again. I'm just going to do it at an angle there. Way down here, these last two, these are the voltage regulators. These are going to provide the plus or minus 15 volts for the opt amps on the input circuitry here. So we got to make sure there. Off of the sill pad 2. There we go. So that's all of them. I need to get the... That's off. I need to get all of them except for these four. Pull you back a little bit. These four right here. Like I said, video recording actually makes it take a lot longer to do a repair because I'm trying to constantly look up at the screen. B, I'm trying to talk and tell you what I'm doing. There we go. We got them all broke free. So technically, we should be able to slide. Yep, the board's sliding. So I'm gonna have to make lots of room. We'll turn it sideways here, so I got somewhere for the board to start going. And let's see if we can get out here. See right there? That's that ground screw that was from that little wire piece, and that's why we needed to slide it this way. That's why it was so important to look between the circuit board underneath here and the heatsink gap and find that wire. So if you don't carefully remove that ground wire, you'll end up sliding this board out and yanking that little sucker, and you can tell it goes over here to where we were looking. You'll end up tearing that up and tearing junk off the board and making a mess. So I'm going to continue to gently slide, watching the FETs to make sure they don't take these sill pads off. And if I encounter any resistance, I look and see why. So you got to just be real careful. I'm getting a little resistance, and I don't know why. Something's not right. Maybe I need to go this other way. Like I said, I always try to be careful. Treat it like it's your own. Ugh. Big, heavy sucker. Let's see if coming this way does us any better. Yeah, I just, for some reason, didn't want to go that way. I'm supporting the heck out of this big old long board. I've got my arm all the way underneath it. Got it. Okay. Carefully set it on my stool. Tore up my hand a little bit. And we can take the heat sink out of the way. Big massive board incoming. All right. Actually, I need to turn it the other way, and I actually need to turn it upside down and carefully lay these wires back in here so we can flip it over. So we're going to be taking out down here. Let's see if I can get a little bit taller shot. Yeah, maybe that will work once I've flipped it around here. Oh my gosh, this thing's huge. Here we go, and we want to get these wires to not be in the way of stuff so it'll sit somewhat even. Here's the area I'm going to need to work on. So this is the output, down here is the power supply stuff. So there's two things we're going to have to do. So I don't see anything else that looks bad. So we're going to unsolder those, and then we're going to take out the driver board. On this style amp, and I'll show you that driver board separate, and I'll probably shoot a little close-up video on taking this driver board out, and maybe, man, my camera is having all kinds of issues. I'm going to have to restart my computer. But in the next video, then we will start pulling these apart and pull this out, and we'll do that because I've got to restart my computer, and we got a lot of work to do. So I'm just going through and adding fresh solder, which is leaded solder, to all the FETs. I've already did one side, and once I get good fresh solder on there, and it's all nice and melted, and this was my big iron, because I'll show you what I've been doing to get these FETs out. Now you could solder suck them, and that would work, and then give them a wiggle. We need to go all the way to here. But what I do is I just add extra solder in my iron up, make sure it's good and ready, and I just get an extra solder on there. For this side, I would, let's just grab this bit, just get a little something to hold some pressure. On the side that was here, I was just able to do it and get them to fall straight out. And I'm just going to rub my soldering iron back and forth between those three, and it just falls out. Don't pull, you want to fall. On this side I was getting it, maybe I can do it right here real quick. Make sure you got plenty of solder on there to kind of help bridge between all those, and that got dirty as heck for some reason. Alright, let's get solder on that edge. Bam! See, it fell right out. That's exactly what you want it to do. Because then you know the vias that are through here did not get damaged. It just fell out because it was all molten. You know, the weight of this transistor can't hurt the vias, and that's the best way I've found to get them out. You can solder sucker them. We will be doing some solder sucker in here in a minute. But that's how I get them all to drop out. I'm going to finish this up. I'm going to clean the holes with the solder sucker and get this all cleaned up. And then we're going to work on this. And it's got a couple bent pins, I think. I'll have to look, flip it back over. So we'll straighten those up, add solder, suck it all out on this big card that we're going to take out. And then we'll have to hang it out. And once they're as clean as possible, you go back and touch them to find the ones that are still connected, and give the card just a little wiggle. Take the heat away and let that solder set back up with that thing wiggling just a tiny bit. And that'll help you just get all that disconnected. Now, you may have to go in with solder wick to help get it a little more. You may have to add more solder back and solder suck a little, but take your time. You do not want to pull a via on these, and I'll record some of that too. Alrighty.